Hey guys, this is Michelle Kittner of the Gulfport School District, and in this video we're going to be talking about proportional relationship problems. This is a two-part video. By the end of both videos you should be able to set up and solve multi-step problems involving percents. The standard that goes with these videos is 7.RP.3. The vocabulary that goes with this standard is all of the listed vocabulary, but today we're only going to talk about percent, markup, simple interest, tax, gratuity, and commission. Before we get into all of that though, let's do a quick review. In standard 6.RP.3c from 6th grade, we introduced percents. So if you're still struggling with that, you may want to ask your teacher for the video or some work that goes with that standard. And remember, a percent is just the number of parts per 100. It's an equivalent ratio where the second number is 100 and the first number is the percent. When we're finding the percent of a number, the first thing we've got to do is change the decimal, and then we multiply the original amount by the decimal. So in this first example, a shirt that normally costs $20 is on sale for 15% off of the original price. So let's just find what 15% of $20 is. So the first thing we want to do is we want to write our percent as a decimal. So if we have 15%, remember if there's no decimal in a number, it's at the very end. And the way we change this to a decimal number is we move to the left away from the percent sign 2 spaces, always 2 because it's hundredths. Okay, so now we multiply 20 times 0.15 to get 3. So the discount, the sale, is $3 off. On the second example, a shop owner buys shoes for $50. He adds a 70% markup before selling the shoes. So we want to find what 70% of $50 is. So we're going to take this 70% and we're going to change it to a decimal. Remember, the decimal is at the end. If it's not shown, it's always at the end of the number. And we move it 2 places to the left to give us 0.70 or 0.7. Then we multiply it by the original 50. So 50 times 0.70 is $35. So 70% of $50 is $35. All right, let's discuss our vocabulary. A percent, we said, is a number of parts per 100. It's an equivalent ratio with the second number being 100. A markup is a percent added to the cost of an item to determine the selling price. So if I buy a pair of shoes and then I want to sell them, if I pay $50 for them, I'm not going to sell them for $50. Maybe I sell them for $70. And whatever that percent of 50 that I increase, that's the markup. It's added to the cost so that I make money. Simple interest, a percent of an amount borrowed that is paid to the lender in addition to the amount borrowed. When you borrow money from a bank, you don't just pay back the amount you borrowed, you pay it back with interest. So you pay back some extra. And the way they figure out that extra is called interest, and it's a percent of the amount you borrowed. Tax is a percent of purchase that is added to the purchase and paid to the government. When the cashier rings up all your items at the store, they give you a subtotal, then they give you tax, and they add those together to get the grand total, the amount you actually pay. The tax is a percent of the cost of all those items. Gratuity is a percent added onto the cost of a service. It's a tip. And you often find that by finding a percent of the cost and adding it on. Commission is a percent of sales amount awarded to the person making the sale. Car salesmen work for commission. So if they sell a car, they get to keep a percent of the cost that was paid for that car. So one thing we want to think about is this percent, all of these deal with percent, but is this percent going to increase or decrease the original amount? If it's going to increase, we'll see some keywords like markup, simple interest, tax, and gratuity. An example of that would be a shop owner buys shoes for $50. He adds a 70% markup before selling the shoes. What is the price? What price does he sell the shoes? So he buys the shoes and he adds something to it and he uses the percent of 70. Decrease, some keywords you'll look for are sale and discount. An example would be a shirt is normally costs $20. It's on sale for 15% off of the original price. What is the sale price of the shirt? The price goes down. Okay. Here's how we figure those out. If we have an original amount, so if there's an increase, we're going to have an original amount. We're going to have what the shirt costs to start, or what the shoes cost to start. And we're going to increase it by amount. Well, the way we find that amount is we multiply the original amount times the percent. Then we add those two together to get the new amount. So the new amount is the largest amount, and we add the original and the increase to it, or together to get it. On a decrease, we're going to take the original amount, we're going to subtract that amount of decrease to get the new amount. So the original amount is the whole total. We subtract the decrease to get the new. And again, to get that decrease, you just multiply the original amount times the percent. It's a percent of it. So once we've decided if it's increase or decrease, we just plug it in. So a shop owner buys shoes for $50. He adds a 70% markup before selling the shoes. At what price does he sell the shoes? So what we're doing is we're finding, we can run through this without using this formula, but the formula helps because we can put it all into one equation. So we could say, okay, let's figure out how much he marks it up for. So the original amount is 50, and he's going to mark it up by 70%. So we could see what the markup is by simply going 50 times 0.70. Remember, we change the percent to a decimal, and then we multiply it. And when we do that, we get 35. So he increased it by $35, and when we added those together, we got 85. But if we want to put that into one equation, we can say the new amount equals the original, which is 50, plus the original times the percent plus the markup. So it's the same thing we did here. We found the increase and added it to the original. Over here, it'd be the same. The original is 20. We're going to decrease that by 15%. So we could go ahead and multiply 20 times 0.15. When we do that, we go 0. That would be 10. Bring it in one, we have 0 and 2. 0, 0, 3. Bring the decimal in 2. So $3. So this amount of decrease is 3. And we'd say 20 minus 3 to get $17. So we can do that as different steps, but as we progress in math, we want to put all those steps together into one equation. So we can say the new amount equals the original minus the decrease, and to get the decrease, we do the original times the percent. Okay. Well, let's look at just the increase for a minute. So we plugged it in, we found our equation, and now we're just simply going to solve for the piece that's missing. So we have n equals, and order of operations tells us we've got to multiply first. So we just bring the 50 down so that every piece is represented. 50 times 0.70 is 35. So the new price is $85. Okay. Now for that decrease example, a shirt that normally costs $20 is on sale for 15% off the original price. What's the sale price of the shirt? So we plugged everything in here, and we said the decrease, the new amount, is the original price minus the decrease. And we find the decrease by multiplying the original amount times the percent of 15, not 25. So the new amount equals 20% Bring the 20 down because we have to multiply before we subtract. And 20 times 0.15 is 3. Now we can subtract. The new price is $17. So you saved $3 when you bought that shirt. Now, what if we aren't solving for the new amount? What if we already have the new amount? Okay, let's look at this example. Sam told Cameron that his new gaming system only cost $225 because he found it on sale for 25% off. Cameron wants to buy the same gaming system, but the sale is over. How much is it going to cost him without the sale? Okay, when you ask yourself, will this increase or decrease the total? I really want you to think about the key words here because we're saying sale, okay? And a sale is going to decrease. The sale decreases the amount. So we're actually going to be subtracting here. Okay. In our examples before, when we decreased and we subtracted, we used this formula. Remember, it's the original amount minus the decrease. We find the decrease by multiplying the original times the percent. So let's put in what we know here. We know that the sale price is going to be $225. We don't know the original price, so we don't know A. We're going to leave it. We still don't know A, so we're going to leave it. And we're going to take this 25% and change it to a decimal by moving it 2 places to the left. Okay, so we have 225 equals A minus A times 0.25. Now this looks weird. It doesn't look like something we can solve. Let's look at it a little bit though. Remember, A is the same as 1A, which is also the same as 1.00A. We can add that decimal and zeros all day long. So we have 225 equals 1.00A minus, now that commutative property of multiplication tells us we can rearrange this to have 0.25A. That looks like something we might be able to work with because it has like terms. The 1A and the 0.25A, we can combine them now because they have like terms. They are like terms. So once we do that, we get 225 equals 0.75A. Now, using algebra, we can use inverse operations to isolate the variable. Since these are being multiplied, we just divide by 0.75 to get A by itself. But whatever you do to one side, we have to do to the other side. So now over here, this is canceling, and we have $300 equals A. So Cameron's going to have to pay $300 for this gaming system. Now, if you want to look at it in a diagram, we can see that this should be 100%. That Cameron took off this 25%, and when he took off 25%, it left 75% more. And we know that this total here was 225. Okay, so we could divide 225 by 3 to get what each of these blocks is worth. And that would be 75. So 75, 75, 75, those are dollars. And when we add all that up, we get $300. So the original cost and the cost for Cameron is $300. Let's switch gears real quick and look at commission. James works for Friendly's used car sales. He earns a 15% commission on all of the cars that he sells. This week, James sells one car for $13,000 and another car for $15,000. How much commission did James earn this week? So let's see. Commission is just a percent of sales. So we take 13,000 times 0.15. He always gets that 15%. And then we'll take 15,000 times 0.15 for the amount that he earned on the second car he sold. Now, 13,000 times 0.15 is 1,950. So on that first car that he sold, if that's all he sold, his paycheck would be 1,950. 15,000 times 0.15 is 2,250. On the second car, if that's all he sold, that would be his paycheck. But to get his total, we add them together. 10 carry the 1, 12 carry the 1, and he earned $4,200 this week. That's how commission works.